Hello guys. This here is not normal ice. In fact, this is often referred as dry ice because it doesn't leave any liquid after it melts. This is due to the fact that this substance is made entirely out of frozen carbon dioxide. It's basically solid gas. It can reach much lower temperatures than normal ice too. It reaches temperatures up to -79°C. The fog that you can see coming off the dry ice is actually frozen air moisture and is common to be visible around very cold substances like liquid nitrogen or inside a freezer. If we drop it in some water, it floats on the water's surface, quickly subliming and letting out a lot of cool fog, often used in some science presentations on fairs. But if we instead of water use a liquid that has freezing point lower than 80 degrees, for example acetone, ethanol, and other solvents, we can create very cold, cooling liquids. We can slowly start to add some dry ice to the acetone, but we must do it very slowly to avoid overflow and splashing. With that temperature, we can liquefy some gases. For example, nitrogen dioxide, with boiling point of roughly 20°C. This brownish-reddish gas is in equilibrium with its dimer to nitrogen tetroxide. The latter's concentration increases with lower temperatures. So if we condense and cool down nitrogen dioxide, we will get mostly the tetroxide, as well as some other nitrogen oxides. All of them are very strong oxidizers, so we will try some reactions with them later. To make the brown nitrogen dioxide, we will use the reaction of sodium nitrite and an acid. This reaction produces highly unstable nitrous acid that quickly decomposes to nitrogen dioxide. The acid will drip on the nitrite and produce nitrogen dioxide, which we can later with help of this apparatus feed into the cold trap to liquefy. I used a test tube for the trap. I lowered it into the acetone and waited to cool down. I then added some hydrochloric acid to the addition funnel. Then I slowly opened the stopcock on the addition funnel and allowed the acid to drip on the nitrite. We can immediately observe an evolution of brown gas. Over to the cold trap, we can see that it's starting to condense into a green liquid. I continued this process until I got a couple of milliliters of the liquid gas. After some time, there was quite a lot of liquid gas in the test tube. So now let's look into some reactions with this strong oxidizer. The first one is with aniline. So I loaded some of the liquid gas in the test tube. And then added some aniline to it. We can see that it immediately reacts. Let's try it again. And again. And this is with some other nitrogen-rich organic compounds that I have around. The first one was with isopropyl nitrite. And lastly with 4-methylmorpholine. So that's it for this video. Thank you all for watching and support, because we hit 200 subscribers recently. See you in the next video. Bye.